So I want to explain a little how this came about. We were talking on Discord, and it was suggested to me by Robo to put a flat backer on here, and I was kind of perplexed because the backer is going to control nothing really on Z but on XY, and I thought that this rail, the thickness of this rail and the size of it, was going to be extremely hard to bend it in the XY direction. So I thought this idea was not going to work. So I was convinced to try it, and my first piece was this one. Even though there's a lot of holes drilled in here, it's got a pretty decent shape. It's got less weight, and it's still very strong. So this I had put on X, the X bar to start, and my Y increased the first time to 4,600 more acceleration. So then I got excited and I said, well, shoot, let me make one for the Y bar, but this time let me make it solid, and then I can always cut it out afterwards. So basically what I had done is taken this bar that was this backer that was on the X bar, and I just moved it up here to Y, and I tested it, and it made X increase. I don't remember the actual number. I'm going to post them in the video. So then when I had to make one for Y, I decided to use a solid one, and it increased even more than this one did. I think it was 900 acceleration. So I decided to just keep the solid one, and then I just made another solid one for the X. Even though it's heavier, it's testing higher, so it seems like a win-win. I could make it lighter, but it's testing higher, so it just doesn't make any sense for me to drill it when I don't really need to. So anyway, that's how this came about. Test 1, no backers, 30mm cube, fast speed. We're going to compare backer versus no backer. Same file. Okay. So here's our top. And on this particular cube, I've got 10% grid fill, and then I switch up to a higher percentage near the top to try to get the top a little bit better. And that way I've got less vertical lines on the outside if they show through. I don't see any. There are. Let me get my little wand here. I see 1, 2, 3, 4. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. There's 5 lines here. They're really faint. Really faint to see. And they're pretty wide. Let's see. Let's see if we can tell how wide they are. Boy, they're hard to see. They look like they're about 2 millimeters apart. This is a 2 millimeter Allen, I believe. And it's about that size. That line is about that wide. And there are 5 of them. So this is X side. I don't know if you can see it or not. One, 2, 3, 4, 5. Okay, so there's X. Corner's pretty good. This is 0.025 pressure advance. Now, for the Y side, I don't see those. I don't see those lines. The layer stacking, I can see some inconsistency there. It isn't much. I can see a little bit of VFA. Here's the other X side. And those same vertical lines are there. Here I've got the seam. And there are those same lines. There's one right there. And it is this wide. It is wide as this Allen wrench. Goes all the way down here. I can see one. It's really hard to see. Seam looks good. Corners look good. PA is about perfect right there. Top looks a little under. So this is the benchmark. It looks like I'll have to grab my caliper. Let's see what we get for a measurement here. on the Z. It looks pretty good. So it's a little tall, not much. You can see that 30.03, but you can see the bottom here is not filled in enough. So my first layer of flow is a little too low. Now I've got chamfered edges on the top and chamfered edges on the bottom. So we can measure top down about halfway. We're a little small, 29.86. And over here, 29.94, 29.94, 29.90. Oh, it's a little smaller here on the X. But I'm going to leave that slice alone. I could correct that and get that the right size, but really what we're looking for is potentially ringing, strange lines, to make a comparison between two of the same files, backed and no backed. So it's a decent looking cube. It was printed fairly quick. I think 30,000 acceleration on the infill and 15 or 20 on the external at 300 external, and I think 400 or 450 internal. So let's do another one with the backers. I'll be back. Okay, we're back for test number 2 with the backer. Input shaping values were not changed, and it's about 6 Hertz difference between backed and unbacked. So we're going to print it anyway, just to see what it does, and then I'll print another one with the correct shaper. So the last test was done about 10 minutes ago. I did not change the file whatsoever, so the bottom's still going to be a little bit under on flow. I want to keep the test as simple as possible without changing any variables except for those rail backers. neck down for setting that right, you're going to hear it crunch a little bit in the top because I guess it curls up or something. I don't know. I need to work on that slicing effort to get that a little bit better. There it goes right there. It went to 45-degree infill at a higher percentage and a different type of filament, a different type of infill. So the bottom is not enough flow, just like the other one. In fact, here's the first one. There's a number 1 on the bottom. It's kind of fading out. So let's see here. We'll start with this. So remember, this is the first one, this is the second one. I can already see that this one is better. There are more vertical lines here. I don't know, they look close. This one looks a little bit better. It's going to be hard to see this in the camera. But in person, this one is better. That same flat line is right here. Same width, same place. It's flat. It doesn't look like it's an artifact. I don't know what it's from. Maybe it's the infill. You can see now my smudge is on there. So far, the second one is better. No input shaping changes. So now let's rotate this. Well, boy, I don't know. They look almost identical. I would say that this one is better. They do look, however, nearly identical. I would say again, this one is better on this side. I can see the same patterns on there on both of them. But they look almost identical. So the corners look the same. The top, in my opinion, looks the same. The same little marks are here, and that's where the filament fell in the hole, and then when it came back by it pulled some of it up, or you know, it's my inability to slice properly. Now here's our number 1. Let's go ahead and mark this one. Number 2. Remark this one. Number 1. We'll go ahead and just cut a little piece out of there for number 1. And we'll cut two pieces out of this one. Now, measuring the same 29.89. Make sure not to get that seam. 29.91. We're measuring about the same. .3001. Now this one has cooled off. See what it did. Stayed the same. Okay. So now we're going to print another one using the recommended shaper with the backers on there. Okay, test number 3 with backers. And input shaper changed to the values recommended for the backers. We got about 9 Hertz on Y and about 6 Hertz on X. I might be saying that backwards. I will describe it in the video. It's going to be 300 millimeters a second external at 15,000, 400 millimeters internal at 30,000, and infill at 40,000. Okay, so we've got our number 2 from the last time, and I'm going to line these up. We're going to start with X, so we'll go like this. So remember, let's put the second one over here. Number 2 and the one I just printed. So, old, new. To me, they look identical. I'm quiet because I'm trying to look at it. I see the same lines. It looks like it's from the infill. Those same lines that are here, that same thickness as this Allen wrench, are still over here on this one. There's a funny little pattern here. It kind of goes diagonally at an angle like this, and it's only as wide as this Allen wrench right here, and it's on both of these. I'll shoot in here closer. I don't know if it'll pick it up or not, but both of them have the same. They look almost identical. I would say they look the same. I would say this one is worse. There's more VFA here. There's a diagonal pattern here again on this edge, the same as there is on this edge. But they, for the most part, look the same. Here's my 2 little notches for number 2. I see my thumbprint is here. They look the same. The same. Same. No different. Old, new. Same ticks here. Now there's a tick here that's not here. I wouldn't expect the top to be any different, but they look the same. The layer line stacking could be better. I do see some that are out of place. Let me see here. But it's pretty fine. It's really, it's not bad at all. There, you might be able to see it there. For layer stacking, I would say that the number 2 is better. So since these are so much the same, let's go ahead and print one more and make it go faster and see if we can get it to really show a difference. I guess just by increasing the speed. So let's mark this one number 3. Alright, so we got 3 ticks, 2 ticks, and a number 1. I'll be back. What I've done is bumped up the speed to 400 millimeters a second, external and internal at 30,000 acceleration, infill at 40,000 acceleration. So this should show a difference in quality. It's definitely faster than I print. Is it acceptable? We'll have to see, I guess. I'm not sure. But let's just see what happens. Using a standard nozzle, the CHT is giving me trouble. It's worn down. I did not change any cooling. It's the same, I think 10%. One of the problems I had today in testing was that the CHT nozzle I've got is not printing as good as it used to, and the tip is worn down a little bit, and I don't have a new one, but I did have a new 0.4 nozzle, and so that's what I've got in there. We're not running any flow that's gonna throw us, you know, out of kilter here. Hot. Alright, we're going to have number 3 out here. Number 3, the last one. Well, I thought they were going to look different. They don't look any different. Well, maybe. There is a difference. There are diagonal lines going this way, and they extend out about this far, going diagonal. This one, it only extends out to this point, about this thick. This one extends out to about here. Can't tell you if it's showing up in the camera or not because the viewfinder is so small. Looking at it from this distance, it's very hard to see. Don't know what the cause of it is. The layer stacking is not as good. It's close, but not quite. Remember, this is the one I just printed. Let's go to this side. I don't know. They look about the same. This one might look a little better. But they're basically the same. Seam looks the same. It's about the same. The layer stacking is not quite as good. There's a little line right here, and a little line right here, and a little line right here, and they might be evenly spaced. Could have something to do with Z. But for the most part, they look the same. Here's that diagonal again, but it only extends out to this line right here. This one has some small verticals here. Let's look at the top. Old one, new one. They look identical. Now let's look at it from the bottom. Maybe we can get a different view of the layers. No, I think we're going to have to go faster. We're going to have to go faster to make it really show, I guess, what's unacceptable. This is not unacceptable to me. So I don't know. Here's the first one. I would say definitely the backer is better. All right.